Welcome to Project Finn. This is episode 2, led by Simone, and we will be prefacing this episode because it concerns the paleontological history of sharks. And despite taxonomical science dealing with most early sharks as separate convergently evolved species, this episode includes false sharks as convergent evolution has led to such similar traits in species that should not be ignored in a history of sharks. Modern sharks are confirmed to have appeared in the early Jurassic, but highly similar species exist as far back as the Ordovician. That's about 400 million years ago. We start with the scene from the Devonian. Towering fungal growths stand tall. On the shore of a river, a fish with lobed fins and primitive lungs drags itself through the mud. Snowflake-like spores hitting its wet snout. It slips back into the river and pursues a shoal of marine invertebrates into the river's mouth on the sea. The bursting pulsations of a mollusk's tentacles pass the fish's side as it makes its way deeper into the sea. Suddenly, a large fish, sheathed in keratinous plates, ambushes this early lobe-finned fish and is swallowed into the abyssally gaping mouth of this predator. The bony predator swims further into the open ocean. Camera pans down, and a handful of meters deeper is a large early shark. Resembling a ray, it swims up, keeping up to this large bony fish, its tail fin thrashing back and forth, its body undulating. Sharks appeared in the early Devonian approximately 410 million years ago, yet it is taxonomically debated whether they went back 450 million years back to the Ordovician. The earliest days of sharks were relatively uneventful. The earliest species were more comparable to rays and more basal cartilaginous fish. But by the late Devonian, as bony fish, such as Dunkleosteus, grew in size, they rose as major predators, especially in lower parts of the ecosystem. This early period of sharks is still debated among paleontologists, especially what officially started the taxonomic lineage. And determining whether the earliest species are cases of convergent evolution or the murky evidence of any species of shark this far back just hasn't been found to draw a solid line between the earliest shark-like species. To be frank, sharks are an evolutionary masterpiece. Their bodies and traits have existed for so long and repeatedly developed independent of each other that they've gone through 5 extinction events, going on 6 because they got the hang of living in the sea so early. They simply are so abundant and have changed so little over time because of how adapted and well-rounded this body type is for life in the sea. A coastal forest of pine-like trees, some towering higher than a 5-story building. Ferns and fungus paint the forest floor as a massive millipede-like arthropod as long as the car slithers through the forest floor. An amphibian trots slowly through the muck. Small fish swim through a stream as a trilobite scuttles underwater. The stream leads to a river opening into the vast ocean, and in the shallows is a small proto shark, nose wiggling as it sifts through the sand, looking for invertebrates to munch on. Going farther from shore, and what mostly looks just like a shark, yet with a bandsaw for a mouth, teeth swirled, the camera stationary as it swims past. It gains speed, and the camera zooms in to watch the fins undulate side to side before it catches up to a nautiloid and ambushes, quickly overpowering their prey. They get their meal. We reach the Carboniferous. It is after the Devonian, and the end Devonian mass extinction event is over. And sharks are taking it like a champ. Their populations are down, but with migrations filling in new ecological niches that open up, and their robustness, they handle the destabilization. Placoderms are virtually extinct, and their absence in the events of this mass extinction promotes the rise of sharks. Quoting a paper published in 2015 by UMaine graduate Laura Salin, small, fast-breathing ray-fin fishes, sharks, and tetrapods, most under 1 meter in length from snout to tail, radiated to dominate post-extinction ecosystems and vertebrate biodiversity. The few large-bodied, slow-breathing survivors failed to diversify, facing extinction despite earlier evolutionary success. Thus, the recovery interval resembled modern ecological successions in terms of active selection on size and related life histories. Body size reduction in vertebrates following the end Devonian mass extinction, page 812 of the scientific journal Nature, This is volume 350, issue 6262. Lawrence Allen and Alan K. Galimberti. With the beginning of the Carboniferous, sharks filled in the role of small pelagic predators, with close relatives to sharks such as eudontids taking charge. The eudontids were the wacky freaks of the sea, with tooth whorls that are shaped like a rolling tape measure or a bandsaw. These whorls specialized in removing ammonites and nautiloids from their shells. The eudontids reached larger sizes during the Carboniferous and dominated relative to their direct ancestors and early members of sharks, who were primarily taking smaller niches, predating on lower levels of the ecosystem, often in open ocean, a notable two being xenocanthus, who are the earliest members of modern frill sharks, or falcatus, who are most comparable to the modern squalidae species like dogfish. True sharks in the Carboniferous and falling Permian period were relatively dormant, though taking up niches and being in large numbers. They weren't notable in the fossil record relative to species very similar that were not true sharks. We continue with a scene from the Permian. The famous Dimetrodon bathes in the sun's light. Its sail up. A creature neither reptile or mammal scurries out of a burrow and snaps up an insect, before drinking from the water of the soft lapping shore. In the water, another freaky tooth-whorled shark swims past the shallow array of sea sponges. Snatching up a nautiloid, a small and late species of trilobite scuttles past a pile of rocks. Going inland into a river that feeds a lake, a massive 5-meter-long frilled false shark chomps down on lakefish and invertebrates, a fine example of the long legacy of sharks in both fresh and salt water. Into the Permian, in the conditions of the Carboniferous, with false sharks, particularly eudontids, thriving, had not only continued forward. The most famous eudonotid, Helicoprion, thrived during the Permian, reaching large sizes comparable to the largest modern sharks, such as great whites. However, particular species in the Permian of true sharks took hold, such as Xenocanthidae, ancestors of modern frilled sharks who live in freshwater, one species reaching 5 meters. The end Permian mass extinction was the worst mass extinction in history of life on Earth, with 96% of marine biomass dying off and going extinct. The Permian Triassic extinction event was caused by massive volcanic activity in what is now Siberia, leaving a large country's worth of land buried in dozens of meters of lava, acidifying the oceans from the CO2 of this lava and bringing global temperatures up more than 8 degrees Celsius in a very short period of time. Most invertebrates, and especially shell marine species, died off from the acidic oceans, destabilizing the ecosystem and food chain for fish and vertebrates. However, relative to most species, sharks took the extinction pretty well, especially given how few species of Permian or Carboniferous sharks were large in size and lofty to sustain in an unstable ecosystem. The majority of Permian sharks were small in size, so primarily they simply migrated to deeper waters alongside their prey and sheltered from surface waters that near the equator were comparable to a hot tub. We enter with a scene from the Triassic. We continue with a scene from the Triassic. On the surface of the sea, the wretched stench of death and rotting permeates. A bloated helicoprion violently bursts, sending guts that send a shoal of fish primally rushing to grab chunks from the surface before diving back down into the lower depths, as the surface is so hot it'll kill them to spend any more time scrounging up rotten morsels. Deeper and deeper down, as the solid cartilaginous and severed whorl of teeth from the dead helicoprion drifted into the deepest of the ocean's blue-green wine. The severed hunk of cartilage and teeth hits the muddy bottom, where small hybodonts and early pseudoshark scrounges up the meat. Well into the Triassic and Jurassic, they'll master their niche of scrounging from the bottom, in freshwater and saltwater alike. The Permian Triassic extinction event marked the transition from the Paleozoic to the Mesozoic, with the Triassic towards the latter half bringing dinosaurs into the picture. True sharks stayed relatively dormant throughout the Triassic, with the Permian bringing synapsids and reptiles. The latter, synapsids, the ancestors of both reptiles and mammals, and the extinction event opening up ecological opportunities. Reptiles took a dip into water and took foothold, claw finholds of the previous large marine predators, with the earliest ancestors of and true members of ichthyosaurs appearing. Thus, most sharks stayed relatively dormant until the Jurassic. However, of note is the mass diversification of hybodonts, who had been a smaller mixed saltwater and freshwater early pseudoshark that first appeared in the late Carboniferous. Hybodonts diversified significantly in the Triassic, widely taking on the role of bottom-dwelling small predators, as well as freshwater predators and seasonally migratory fish comparable to modern-day salmon. By the Jurassic, the transition period was marked with another mass extinction that created a major drop in marine reptile populations. Yet ichthyosaurs and plesiosaurs pressed on, taking on the role of marine apex predators. Meanwhile, hybodonts were stunted by the extinction event and a lineage split leading to modern lambdaforms. Paleoarchaeus is the major early genus of lambdaforms that appeared. Simultaneously, most modern lineages of sharks were appearing and spreading out, such as pseudohina angel sharks, and the largest taxonomical branch by population and diversity, carchariniforms. Overall, the Jurassic was a period where sharks blossomed, but did not swim rampant, as the ichthyosaurs still kicked, or splashed, pun intended, around on the stage of dominance. A young mosasaur violently rips a hunk of flesh from a smaller plesiosaur, easily tearing off a fin in the upper body, including the heart. Its blood permeates the water as the mosasaur scarfs it down, the leftovers falling into the shallow seafloor where crabs and a pair of angel sharks scavenge off of it. Competing in size, a large member of the true shark species, Tychodus, ambushes and snaps the neck off of a marine reptile, taking its time to savor the day's meaty plunder. Ravenous fish reaching 2 meters long scarf down another fish half its size with a frantic and rabid nature. Welcome to Hell's Aquarium. The Cretaceous was arguably the peak of sharks. We had the wide diversification of modern lambdaforms, the appearance of angel sharks, and most notably the western interior seaway, also known as Hell's Aquarium. During a long swath of the Cretaceous, what makes up from modern-day Louisiana, up cutting through the Great Plains, and northern and west central Canada, reaching a peak width of 1,000 kilometers wide and 750 meters deep. What makes the western interior seaway so notable was the difference in abundance of predators. Hell's Aquarium gets its name for the shallow, warm, and massive saltwater body that it is, and how it sustains so many predators with its characteristics. The seaway had large great white analog Cretoxyrhina and the massive Tychodus, simultaneously rushing alongside the apex fish, where apex marine reptiles such as mosasaurs, medium species of sharks such as Swallocorax existed alongside massive plesiosaurs who specialized in the same smaller prey. The abundance of predators and prey in Hell's Aquarium allowed for not only the specialization in specific niches and levels of the food chain, but multiple species sustaining themselves out the same niches. While deciduous forests shelter piggish and large mammals, flowers blooming on the edge of a beach, shark pups swim about in an intertidal zone lined with the tall grasses, occasionally being ambushed by a pack of cetus diving into the intertidal zone. That'll be the common ancestor of today's whales. Crabs scuttle further offshore on the rocks as the shark, apart from swallow-forms, snatches up a crab. A coral reef is patrolled by a cluster of medium reef sharks as a shrimp peeks out between the corals. A great white-sized shark takes down a large fish in the open ocean. Going on to the late Neogene, and a megalodon chomps off the fin of a large whale. Taking another fin, the whale bleeds out as seabirds try to dive for scraps. The megalodon feasts as below it. At the bottom of the ocean, a cluster of sharks feast on a whale fall, a newfound temporary pocket ecosystem in the Midnight Zone. The most famous of the mass extinction events is the KPG. The asteroid that impacted modern-day Yucatan Peninsula has killed off the non-avian dinosaurs, and mammals are getting big and abundant, though without very big brains. Sharks took it like a champ, and besides the early Paleogene, where whales and marine mammals hadn't appeared yet, the period was an analog to the place of modern sharks in the ecosystem. Sharks at the time were about the same size as today and filled the same niches, though within 40 million years ago and 25 million years into the Paleogene, large cetaceans such as Basilosaurus began to appear, which sharks adjusted to live alongside and incorporated into the niches and ecosystems that they affect. This brings us to the Neogene. The abundance and stable presence of whales and seals has allowed for the most widely admired shark to appear, Megalodon. With so many whales, one shark species capitalized on the warm temperatures of pre-quaternary times, Megalodon, the whale chompers. Otherwise, in the Paleogene, Neogene, and the Quaternary period, sharks have remained relatively stable to what we know, besides Megalodon, that is, who went extinct 2 million years ago during the transition period between the Quaternary and the Neogene. That brings us to today, the Holocene epoch of the Quaternary period. Today, fishermen pile sharks onto the deck, bycatch of a raid on the seafloor with monstrous nets. Without mercy, their fins are hastily ripped off with knives, tossed into a bucket without care, and then tossed back into the sea to die in suffering and a painful death. Today, the nets on seafloor trawlers catch and slaughter seafloor-dwelling sharks en masse, who will die in the nets or be thrown back with infections to rot away in the sea. And today, political groups convene to argue whether to pollute and mine the last stronghold of shark populations undisturbed by humans, discussing the potential profit margins of mining deep-sea metal modules, while disregarding the fact that no part of the ocean besides the deep sea have sharks not faced their massacre by humans. Maybe this will be their extinction, the end of their tale. Maybe after 400 million years ago. Who is to say? Not like it is you in this 1 in 400 millionth fraction of the shark's existence. That will be the end of episode 2. This was written and done by Simone Trombley, a part of the Project Fin team. Thank you for listening. Goodbye.